Hi, Grandma here. You can read our blog at MakeCode.com. And that's my pug, Bean. He's trying to help. Okay, this is the coordinates game. The idea is to break the glass corresponding to the position of the displayed coordinates, like 5, 2. Okay, let's just do that. 5, positive, 2, positive. Got a green block, that means that is correct. Okay, let me give you a little bit more tour of the grid. The cyan block is the origin. It's the center of the grid. Each direction on the grid, this axis is indicated by the white tab at the end, just so that you can keep your place if you can't see the cyan block. So there are 5. Positive 5 is the maximum value for the x and z coordinates, and negative 5 is that corner coordinates. Okay, so let's start from the beginning. Start a new game. Okay, now x and z is oscillating between E and S, reminding us that x and z are directions E and S respectively. Then when it gets through with a couple of oscillations, it will give you the first position coordinates. So 2 minus 2 would be 2 above the origin and minus 2 to the left, which is what? You say. Okay, there it is. I got that one right. 5 positive minus 2. Okay, minus 2, 4. Okay, we're doing pretty good. Okay, minus 1, 4. Okay, that would be that block, but let's get one wrong to see what happens. Okay, it's showing me where the right one would have been, and then it turned that one red. Okay, I missed that one. Now notice that it put back the glass block. It repaired that so that later, when I get that position specified in these coordinates, I can break it correctly. Okay, minus 4, 3. Okay, I'm sure you get the idea. 4, 1. Takes a while to play a game. At the very end of the game, once all the blocks are either red or green and cyan, because this block always turns back to cyan no matter whether it was a red or a green, it will display, where the coordinates are displayed, it will actually display your percentage score as a percentage of the right answers of the total. So now, this program was just way challenging to write. I actually had a version of it running 6 weeks ago, and I made a short video about it on YouTube. Then I started having problems. Always in rare conditions, weirdnesses would happen, or in programming we call those anomalies. And basically, it had to do with the fact I was using an asynchronous forever loop to do the repairs, and there were situations in which that just did not work. Very rarely happened, so it was very hard to test. The other problem I had, and I to this day don't understand why, although it's now gone away. Sometimes when I would break a white glass, it would not fire the event. And I'll show you more about that in the code. Now I have found that the program is highly reliable, and it's also way easier to understand, and it just usually works like a charm. Now the trouble with programs is the player. So this game just runs along doing what it should do for 2 and judging your answers, -5, 4. Just chugs along happily. But players will be players. They will do things that are wrong. For example, they might break a green block by mistake. Did you see that get fixed? Fixed it. Well, what about a red block? Now, the player should never break a red block, but you cannot control the player. Now, also, the player might break one of these tabs. Oops, there it came back. Cool. Or he might break grass. Yep. Players might do any darn thing. Okay, so that is what the game does. And of course, I have never gotten an all green grid, but it's my goal. And by now, I have pretty much mastered coordinates as they are used in MakeCode for Minecraft. But I keep playing, hoping to get an all green 100%. So let's take a look at first the design of the code. Okay, here we have, this is the overall design. And it's important to understand this before we actually get into the code. Oops. Okay, first the program initializes by drawing the coordinate grid and the compass. And we build a list of positions on the grid. So this list will be, every time we display a position, it will take that position out of the list until eventually there are none left and the game ends. So this light blue arrow, as is this one, indicates that this is being called as an on-chat, and so that it's asynchronous. So this will launch post unused position and initialize will finish rather than waiting for it to come back. So it posts an unused position, as a pair of coordinates if there's a position available. If there's no position available, the game ends. Now, once a position is posted, it's like a question to the user. Pair of coordinates, like where, that's the question, where is the position on the grid? Break the glass. So at that point, it just exits and it waits for the broken event. In other words, nothing happens. Waiting is kind of a conceptual thing. There is no wait in the program. It just means this exit and the program does nothing until the user breaks the block. So when the user breaks a white glass block, the question is, was that the right answer? In other words, does that block correspond to the posted coordinates? The way the program tells, I think, is kind of sneaky. What it does is it tests to see if there's error, if there's error at the position that is the answer. Now, the answer was remembered over here when the coordinates were posted. So it tests that remembered answer against to see if it's error, and if it is error there, it's correct. And if there's not error there, it's wrong. So it updates the blocks to either red or green, and it posts a new position and exits. Now that's a blue line over here to post a new position, indicating that it launches. This is an on-chat command and exits. I don't quite know what would happen if it well, I think I do. Basically, you need this to be an on-chat command, so this routine can exit. Otherwise, you would probably get several copies of this running, and you'd like to make yourself crazy. Okay, so it goes around kind of in this circle, posts a coordinate, processes the event, posts a coordinate, processes the event, until all the coordinates are gone, and then program ends. Okay. Now, let's take a look at the code. Let's take a look at the code. This is the code. Ooh, terrible. Well, it is a pretty big program. And right now, I actually think, pretty sure, I understand every line in it and why it's there. And I have had so many versions of this as I was trying to come up with one that would never have an anomaly. Never act weird. And I think this one is that. So this side, on this side is the run command that launches the program. And this is all just initialization. It builds the grid, it sets the origin, sets the print position, all that stuff that you need to do to get started. Once that's done, that code never runs again. This code right here initializes the list that keeps track of the positions, and this one actually finds an available position in the list. This code actually posts a coordinate. So when this finishes, it launches post a new coordinate, which puts a pair of numbers in the sky as the two coordinates for the chosen position, available position. Once that's done, it just exits and sits there until one of these two events are fired. Whoops, I didn't really want that. Until these two events are fired. Then it actually does this function, which determines whether or not the answer was correct and processes it accordingly. Now, everything from here over, well, I tried to draw a line. Everything from here over, it has to do with repairs. This routine is run at the end of every break because that's where we need to repair the block that might have been wrong, blah, blah, blah. These are run if accidentally a green one was broken or accidentally a red one was broken. This runs if accidentally the glass, I'm going to stop doing that. The grass was broken, and there runs if there was a tab broken. Okay, an axis tab. So that is the code. When you break it down like that, it's actually relatively simple. So let's look at a few of these. Okay, pause. Okay, I thought about this, and I think I'm better off to let you read the blog for the details about this program because it's just a little too complex to explain on the video. And besides, I want you to read my blog. So for example, the run on chat command that launches the program, every step of it is clearly described in this list. So one of these steps will correspond to each block in the code. You couldn't ask for better than that. And then next is this routine that it posts the new coordinate. And again, every step is explained in the block. And the available positions list was really at the core of this program. It's also thoroughly explained. Now, an interesting thing about this is that having a list of positions is an undocumented feature in MakeCode for Minecraft, or at least if it's ever documented, I haven't found it. If you look up lists and arrays, it will tell you that you can have lists and arrays of numbers and strings. It does not mention positions. But usually a coder shouldn't use an undocumented feature because it might change in the next release. But in this case, first of all, I'm 76 years old and I can do anything I want. But also in JavaScript, a list of positions makes total sense because you can have a list of objects and positions is an object. You didn't want to know all that. At any rate, are the two routines. And then the onBroken event is the next really important thing. And again, here, every step of the onBroken event, every block is explained in the list of things that does. And then last is all these repairs, and again, they are explained. The repairs are actually pretty cool. Now, you can get this code. This is not a correct. I'm going to paste in the correct URL for the code at my blog, and then we will all be living happily ever after. Okay. There. Okay. I really enjoy this program. It was very fun to write, even though it was so hard. I had nightmares. I woke up with great ideas that didn't work. But some of them worked. And it just took me forever. And again and again and again, I changed it. And finally, I totally understood it. And I totally got it right. And that makes me extremely happy. -1, -3. Now you can imagine I've been testing this program forever and my fingers are sore. I've been spending so much time testing it. I test it while I watch TV. Seems like I test it in my sleep. I take my laptop with me and test it when I'm waiting somewhere. So it takes a lot of testing. I tried to get the girl to test it, but she didn't have the patience to do it. I think she was too busy skating or something else that a 12-year-old should be doing. Okay, that is the end, and I really appreciate your time, and I hope you will go to the blog and develop a thorough understanding of this program. Thanks for watching. This is Grandma out.